welcome to this explainer. Picture this. It's 2 a.m. on a Tuesday. Suddenly, your pager is just screaming at you. The core payment system is completely down, and the alerts? They're piling up by the second. In a super high-stress IT incident like this, every single tick of the clock is literally costing the company money, trust, and its reputation. You're the IT support engineer on call, and you've got to find the root cause, like, right now.
So, I want to pose a critical question to you. When the system is down, exactly how fast can you check your APIs? Look, recent industry reports show that the average enterprise manages over 15,000 API endpoints today. 15,000! If you're trying to find that one broken link in a massive chain of microservices by manually firing off requests and kind of squinting at the responses, you're fighting a losing battle. It's just physically impossible to check that kind of surface area by hand during an active outage.
Okay, let's dive into this and look at the stark contrast between your options here. On the one hand, we've got manual checking. It's slow, it's incredibly error-prone when you're panicked, and honestly, the worst part is that it entirely misses silent failures. You might see a success message and just assume things are fine, completely missing the deeper issue. On the flip side, we have automated triage. Fast, super reliable, and it tests entire multi-step workflows instantly. Today, we're going to move you away from the manual panic and into the automated calm. So here's our quick roadmap for the next few minutes. We'll cover 1, the incident response problem, 2, writing your first test, 3, validating time and content, 4, chaining variables for workflows, and 5, the 60-second resolution. Let's get right into it.
Section 1, the incident response problem. The core problem.
So the heart of the issue is something we call 200 OK but broken. It's a silent failure. See, in traditional monitoring, an alert might not even trigger if the server is technically awake. An API can return a 200 OK HTTP status code, right? But silently, it's delivering incomplete, incorrect, or completely outdated data. So the absolute crucial takeaway here is that just pinging an endpoint to see if it's up isn't enough anymore. You actually need to know if it's returning the right data in the correct format under real-world conditions.
Section 2, writing your first test. Automated defense.
Now, I want to reassure you right out of the gate here, you absolutely do not need a software engineering degree to do this. The Postman test tab uses really simple JavaScript snippets. It validates responses entirely automatically, so you don't have to visually scan lines of JSON code yourself. It's built to be accessible. In fact, Postman gives you these easy copy-paste friendly snippets right there in the interface so you can literally get started immediately. It totally replaces those manual visual checks. Let's say we're pinging a test endpoint using Postman Echo. Here's what your very first basic test looks like. It's literally just a couple of lines of code. The pm.test wrapper there, that simply gives your test a human-readable name. In this case, status code is 200. Inside that function is our assertion, pm.response.to.have.status200. When you hit send, Postman automatically runs this script against the response. If the server throws a 404 not found or a 500 internal server error, this test instantly fails and the interface turns bright red. Boom, that's your first automated line of defense.
Section 3, validating time and content, catching regressions.
Now, what's really interesting about this is how easily we can start catching degraded performance. We've kept our status 200 check, right? But look, we've added a second test right beneath it. This one checks if the response time is less than 500 milliseconds. Using pm.expect, we grab that response time property and just assert that it must be below 500. During an incident, an API might technically give you data, but if it takes 10 seconds to do it, your front-end apps are going to time out and crash. This simple script catches those performance regressions instantly.
And here's the final piece of our endpoint validation puzzle. Let's say we're pulling user data from JSON placeholder. We parse the response using pm.response.json, save it to a variable we'll call JSON data, and then we actually verify the data payload itself. Here, we expect the ID field within that data to equal 1. This totally solves our 200 OK but broken problem. We aren't just asking, hey, are you there anymore? We're asking, did you give me the exact data I requested, and did you do it in under half a second?
Section 4, chaining variables for workflows, multi-step workflows.
Let's move on and see how this builds, because this is where the magic happens. Think about a realistic scenario during an outage. You can't usually just ping a get payments endpoint out of nowhere. First, you have to authenticate. You need to send a login request, grab the secure token from the response, and then carefully paste that token into the header of your next request. Doing all that manually while a fire is burning takes precious minutes. But we can chain variables to automate the whole shebang. Step 1, send the login request. Step 2, extract the token using Postman's environment variables. Step 3, automatically use that token in the very next request.
Right, so here is the exact, totally straightforward code snippet used to grab a token from a response and save it for later. Just like before, we parse the JSON data, but then we use pm.environment.set. We name our variable token, and we tell Postman to look inside the JSON data and pull out that specific token value. Postman takes that and securely stores it in your active environment. So now any of your subsequent requests can simply use the placeholder token in their headers, and Postman dynamically injects the fresh token every single time. It is completely hands-off.
Section 5, the 60-second resolution, automated execution. And this brilliantly illustrates the true power of what we've just built. Instead of frantically clicking through tabs, you hit exactly one button, Run Collection. Postman executes your mock-off login against Postman Echo, grabs and saves the token, passes it right to the Get Payments endpoint, and verifies all the data schemas. The collection runner then spits out a super satisfying all-green report. At a single glance, you have definitive, rock-solid proof that the entire API workflow is healthy, the data is correct, and the performance is completely within limits. 60 seconds. That is the immense efficiency gained here. Think about it. What used to take panicked minutes of manual clicking, copy-pasting, and squinting at cryptic error logs now takes under a minute of automated execution. When that 2 a.m. pager goes off, your first action is just running this exact suite. Within 60 seconds, you know exactly which microservice is failing, what step in the workflow is broken, or, hey, maybe the system has already fully recovered. I really want to reiterate this core, incredibly empowering takeaway from our source material. You don't need to be a developer to write these. API testing is simply no longer locked behind complex software engineering roles. As an IT support engineer, you have full access to these test automation capabilities right now, today. By bridging that gap between manual troubleshooting and automated validation, you seriously become an absolute game changer for your incident response team. So, I'll leave you with this final provocative thought to consider. If your most critical APIs went down right now, would you really rather spend hours frantically clicking through requests or just 60 seconds watching the automated runner turn green? The tools are sitting right there in front of you, just waiting to be used. Take an hour this week, open up Postman, write your very first status code assertion, and start automating your triage. Thanks so much for joining me on this explainer, and happy testing.